So suppose you have an array with, let's say, 4 elements. An example is this array being an array of integers. So let's say our array here has integers 1, 2, 3, and 4. Now the goal will be to transform this array such that everything here is a product of all the elements of the array except the position that we are in. So this means our new array, let's say when we are at position 1, we will not consider the element in position 1. So we will multiply 2 by 3 by 4, and that will be 24. As we keep moving through our array, now we will be at position 2. Now we want to multiply everything else except the element at position 2. So we will multiply 1 by 3 by 4. So that gives us 12. And then when we're at position 3, we multiply everything else except our element at position 3. So we take 1 times 2 times 4, which is 8. And then we do the same now for the last element. We will multiply everything else except the element at the 4th position. So 1 times 2 times 3. That gives us 6. So you can see what we have done is we have transformed our array into products of elements except the position in which an element is. So this is our original array, then a series of operations based on this array. So I will be executing this code in Java. But before I execute, we need to talk about the implementation. So now our function is going to take in this array, of course, and there is a series of operations that we're going to do. Now, this method is probably the brute force method, but all in all, at least it solves the problem. So there are more efficient methods, such as dividing the array into the parts which we will multiply, and then we multiply those products again until we get the answer. But for this particular example, we will be looping through this array. So we will start at position 1. We find out the remaining elements, and then we put them into an array. So how I did this was probably using a hash map or a hash table. So probably at index 0, I figured out everything that is not in index 0. I sort them into an array. So that array will be an integer mapping my elements to a list. So this is how I took the situation. So at index 0, based on 0-base indexing, this will be from element 0 to element 3. So if I start, this is element 0, element 1, element 2, and lastly element 3. So for this, at index 0, we know that our array will be elements 2, 3, and 4. At position 1, we know our elements will be 1, 3, and 4. At position 2, we know our elements will be position 1, 2, element 1, 2, and 4. And lastly, at position 3, our elements will be 1, 2, and 3. So now after this, we have formed new arrays or new lists. So we have 4 unique lists. Now I can just take the product of every element in this list. So the product of 2 times 3 times 4 will give us 24. This will give me 24. This will give me 12. This will give me 8. And this will give me 6. Now I can just take these results and put them into our main array, our main new array. So our answers will be 24, 12, 8, and 6. But how will we implement this? So when we look at the Java implementation, right, so now for the implementation, we have 3 functions. So product except self, what it does, it takes this array over here, and then it performs a series of operations. The second function we have, although it's not a must, but just for reusability and clarity, you can add it. It's the function that gets the product of all of the elements in the array. So like 2 times 3 times 4, it is the function that returns 24. So this will be an integer. So as you can see, int. And then we have convert to array. So basically this is a unwritten function, basically just converting our list to an array, nothing big. So our 2 key functions mostly will be to get the product and how we get the product. So now, so you can see first we take in an integer array, and then we create a new list called product list. So this list is the one designed to look like this. So we create space for it in memory. Now, how I go about creating this hash map is basically probably O of n squared, because for each of the elements, I'm creating a list. Yeah, so now for when we are at position 0, that is when we're over here, I want to create this, and then what do? First of all, I made a map. Sorry for forgetting. So there's a map here. It maps an integer to a list of integers. So it does 0 to this list, 1 to this list, and so on and so forth. So yeah, there's a map. Yeah. So I call this map numbers to multiply because it gives us the numbers to multiply at when we have the keys. So yeah, back into our function. We will understand the map better as we iterate through the main list. So we're taking in this in our function. Let me highlight it in blue. Yeah, we're taking in that blue array. And when we take it, we create a product list. And now we want to put values, keys and values to our hash map. Now we start looping. We're using a for loop. For int I is 0, I being less than numbers.length, and we want to increment I every time after we've created a key and a value for our hash map, which is numbers to multiply. So now for each position, remember position 0, I want to create a list that associates with that position. So when you're at 0, there's two things that I do. Remember, when I'm at position 0, I don't want to include that element at position 0. I only want to include elements which are not in that position. So what do? I create a new integer k, initialize it to 0. And then I don't want k to be equal to I. If k is equal to I, then I increment the value of 1. So picture this. K is initially 0, I is initially 0. So k is equal to I, 0 equals 0. But remember, we don't want to make a list of products that includes our elements at position 0. So to navigate this, I incremented I by 1, and I set that value k. So now k is 1. So now we start looping from 1. Otherwise, we set k to 0. So 0 is probably the lowest element. Now, our while loop will check while k is not equal to I, and this k is less than the length of this array. We want to add these elements. We want to add the element at. So initially we were making sure k is not equal to I. So initially k is 0 and I is 0. So what we do now, we set k to be a position ahead of I. So now k will be at this position over here where 2 is. So based on array indexing, that's position 1. So now our first while loop will say while k is not equal to I and k is less than the array length, we want to add the number at the kth position, and then we increment k. The moment k will be equal to I, we want to jump out of the loop, and then we increment the value of k. Now, when k will be equal to I, given that we're in the middle of this loop, we still want to loop over the remaining elements. So that is the function of our second while loop. We're just adding the remaining elements into this list at this point. And then finally, we put our hash map. So position 0 will have an associative list that has elements like this, 2, 3, 4. And position 1 will have an array this size, and this one, and this one. So after that, now we can do a set of integers. Now every key in our hash map is unique. So 0, 1, 2, 3. Those are unique values. So we can put them in a set. So that is what we're basically doing here. And then now each key is a list. So now I named a variable here called production square. That's just where we need to produce the result of the multiplication of the list. So now for each element in this set, all right, for each element in this set, this element will map us a list that we're getting here. So that list of integer, we want to get its product. So we get the product and then we add it to our product list. Where's our product list? We had defined it here. We add it to our product list. So this is a bit unnecessary. Yeah, that will work. Another thing, what we do finally, we convert this product list to an integer, an array of integers. And that is basically the function of this part here. All right, so I'll save this and I'll do a test run. So we have our array numbers. So I first need, of course, to create the object. I just named this class matrix multiplication, but you can name it anything really. And now we have a list. So that list will be generated after we transform these numbers over here. The numbers go into our function, and then we want to print out each of those numbers. So let's test it out. All right, so 1, 2, 3, 4 gives us 24, 12, 8, and 6. And that is the same that we have here. That is the same result we have. Let me try and tweak this a bit. You can try any number. All right, that needs a bit of mental math, but it's fine. So let me see. 6, 5, 3, and 4. So 5 times 3, 15. 15 times 4 is 60, which will be our first element. And when we're at position 5, 6 times 3 times 4. All right, 4 times 3 is 12, times 6 is 72. And when we're at position 3, it is 30 times 4, which is 120. And when we're at position 4, it is this remaining elements, which is 30 times 3, which is 90. Right, so that's how to solve the issue with sorting elements and getting the products. Another thing, how to get the product is basically an accumulation. So we basically accumulate. So first of all, our product will be, let's say we have 3 elements in the array, 1, 2, and 3. So we get the first element that will be only 1, and then we multiply it by the element next to it, and then we repeat the process. Notice that I set the looping to array size -1. That's because at some point it will try to check the next element, but it will be out of bounds due to the limitation of the size. So you have to consider that. And yeah, all in all, that's how to solve the problem. There is an easier way where you can just subdivide the array. So let's say we're at position 1. You just make an array by itself, multiply those elements, return an answer. We're at position 3. You just take 2. When we're at this position, you just take 1 times 3 times 4. 1 will be an array by itself, 3 and 4 will be another array. Multiply the elements in that array by now the other array, which has already been multiplied by. So you continue subdividing the arrays, getting the products, multiplying the products together, and that is probably a more efficient way that we shall cover. Yeah, so basically that's it. That's how to solve. That's one way to solve the issue of array multiplication. Yeah.